Hello, friend. Welcome to Science for Sleep. Whether you have been here before, or you are just discovering this quiet corner tonight, this is a calm place to slow down, learn something gentle, and let the day slowly fall away. Tonight, we are resting beside one of the most powerful and familiar animals on Earth, the bear. Even the word feels heavy and simple. It brings to mind a dark shape moving between trees, a broad back passing through tall grass, a paw pressing softly into mud, a large animal standing still at the edge of a river, watching the water move. Bears live in many parts of the world, from the forests of North America to the mountains of Europe and Asia, from Arctic sea ice to the bamboo forests of China. There are 8 living species of bear today. Black bears, brown bears, polar bears, giant pandas, sun bears, sloth bears, spectacled bears, and Asiatic black bears. Each one is different. And yet, even from far away, most people know a bear when they see one. Part of that recognition comes from the way bears stand and move. A bear walks on the full soles of its feet. This is called plantigrade walking. Humans do this too. So when a bear steps forward, its heel and toes meet the ground in a way that feels strangely familiar. A wolf walks more on its toes. A cat moves with a lighter, sharper kind of balance. But a bear places its whole foot down, pressing weight into the earth with a slow, grounded motion. If you enjoy these quiet journeys, you're welcome to subscribe. And if it feels natural, to leave a comment sharing where you're listening from tonight. It helps others find their way to this calm corner of the world, one sleepy traveler at a time. The quiet continues here, just as it is. A bear can also rise onto its hind legs. It does not do this to act like a person. It often does it to smell better, see farther, or understand what is nearby. But to human eyes, the sight can feel almost haunting. For a moment, the bear becomes tall. Its shoulders lift. Its front paws hang in front of its chest. Its face turns toward the air, and the animal seems to cross some quiet line between wildness and recognition. That feeling is one reason bears have stayed so deep in human stories. People have painted them, hunted them, feared them, honored them, and placed them in myths for thousands of years. But the real bear is more interesting than the symbol. A bear is not just a large predator. It is not built like a lion, made for a sudden chase across open ground. It is not built like a wolf, made to run in a group for long distances. Most bears are built for something broader. They are built to search, to smell, to dig, to climb, to turn over logs, to break into rotten wood, to pull fish from rivers, to remember where berries ripen, to find food that appears only for a short time, then vanishes for another year. A bear's body is a kind of living compromise. It has the strength of a hunter, but the patience of a forager. It has claws that can tear into flesh, but also pull apart soil and tree bark. It has jaws strong enough to crush. But in many species, those jaws may spend much of the year working through roots, nuts, insects, grasses, and fruit. This is what makes bears so quietly complex. They can seem slow, but they are not simple. They can seem heavy, but they are not careless. A brown bear may spend hours feeding on salmon in Alaska. A black bear may climb a tree to escape danger or reach food. A polar bear may wait beside a seal-breathing hole on sea ice, using stillness as a hunting method. A giant panda may sit in a green forest and spend much of the day eating bamboo, using a special wrist bone like a false thumb to grip the stalks. All of these animals are bears. Each one carries the same ancient outline in a different direction. And beneath that outline is a much older story. Because bears were not always the large forest and ice animals we picture today. Their bodies were shaped over millions of years. Their feet, teeth, claws, noses, muscles, and winter rhythms all came from a long chain of change. The bear at the river is not only an animal in the present, it is also a survivor from deep time, a living result of hunger, climate, migration, birth, sleep, and memory. So tonight, we begin with that simple image. A bear moving slowly through its world, a familiar shape, a quiet giant, an animal we recognize before we truly understand. The bear moving through the trees feels complete, as if the world always had bears in it. But the animal we recognize today is a late arrival in a much older story. Long before a brown bear stood in a salmon river, or a polar bear crossed sea ice, or a black bear climbed into an oak tree, there were smaller mammals moving through ancient forests. They did not yet have the full bear shape. They were not the heavy, round-eared animals we picture now. They were quicker, lower to the ground, more lightly built, and they lived in a world that was still changing around them. Bears belong to a family called ursidae. That name comes from the Latin word for bear. Ursidae sits inside a larger scientific group called carnivora. Carnivora does not mean every animal in the group eats only meat. It means they share ancestry with mammals that evolved special teeth and skull features for gripping, slicing, and processing animal food. Cats, dogs, seals, raccoons, weasels, hyenas, and bears all belong to carnivora. But bears sit on one particular side of that family tree. They are part of the caniform branch. Caniform means dog-like. That does not mean a bear is a dog. It means that far back in evolutionary history, bears are closer to dogs, wolves, foxes, seals, weasels, raccoons, and skunks than they are to cats, lions, leopards, or hyenas. It can feel strange to picture a bear this way. A modern grizzly can weigh several hundred pounds. A large male polar bear can weigh more than 1,000 pounds. A wolf, by comparison, is narrow, long-legged, and built for travel. But family trees do not follow outward appearance alone. They follow bones, teeth, skull structure, DNA, and deep ancestry. A bear and a wolf look very different now because they traveled down different paths. One path led toward pack movement, long pursuit, and lean bodies. Another path led toward strength, smell, seasonal feeding, digging, climbing, and stored fat. The early bear relatives were not yet locked into the forms we know. Some were closer to small forest carnivores. They could move through trees, search the ground, take animal prey, and likely feed on whatever the forest offered. They were not pure hunting machines. They were flexible animals. And flexibility matters. In a changing world, An animal that can eat many things can survive when one food disappears. During the Miocene epoch, beginning about 23 million years ago, Earth's climates and habitats kept shifting. Forests opened in some regions, grasslands spread, mountain ranges rose. Seasons became more important in many places. In this kind of world, a body that could adjust had value. One important early bear-like animal was Ursid. It lived roughly 20 million years ago. It was much smaller than most modern bears, closer in size to a medium dog in some species. Its body was lighter. Its limbs were not yet the great pillars of a brown bear, but it carried traits that point toward the bear family. It helps us picture a stage before the full bear had arrived. Not a tiny version of a grizzly, not a missing modern species, more like a flexible ancestor standing near the beginning of a long experiment. Over time, some of these animals grew larger. Their skulls changed. Their teeth became better suited to mixed diets. Their legs and feet became stronger. Their bodies began to favor power over speed. The story of bears is not the story of one sudden transformation. It is a slow gathering of traits. A better nose, a heavier shoulder, a broader paw, a stronger jaw, a body able to eat meat, fruit, roots, insects, fish, or plants when the season demanded it. The bear we know is the result of many small changes stacked across millions of years. That is why a bear can feel so ancient when it appears in a forest. It carries more than size. It carries time. The modern bear is not the starting point. It is the late shape. The finished outline we see after countless older forms tried to survive in forests, coasts, mountains, and cold northern lands. And once that dog-like branch had begun to lean towards strength, appetite, and patience, the bear body started to become something very different from its smaller ancestors. A frame built not just to chase life, but to gather it, store it, and endure. That ability to gather food, hold energy, and endure did not appear all at once. It formed slowly across deep time, as early bear relatives met changing forests, cooling seasons, open ground, and new kinds of food. During the Miocene epoch, from about 23 million to 5.3 million years ago, the world looked partly familiar and partly strange. Grasses were spreading across many continents. Forests were shifting in size and shape. New grazing animals were becoming more common. Predators had to adjust to landscapes that did not stay the same for long. Among the animals living through that long stretch of change was Ursid. Its name means something like dawn bear. Ursid was an extinct genus, which means a group of related species that no longer exists. It is often treated as one of the important early bear forms because it stood close to the path that later led toward true bears. Some species of Ursid were much smaller than a modern black bear. A person looking at one from a distance might have seen something closer to a sturdy, tree-climbing carnivore than a heavy bear. Its body still carried a lighter frame. Its legs were more suited to agile movement. Its skull was smaller than the wide skulls of later bears. Yet the outline was beginning to lean in a new direction. The bear body slowly became heavier, because size can protect an animal and open new feeding options. A larger animal can push aside rivals at a carcass. It can dig deeper into soil. It can break open rotting logs where insects hide. It can carry more fat through hard seasons. Those advantages matter when food arrives unevenly across the year. The limbs also changed. Later bears developed powerful forequarters with strong shoulder muscles and heavy front legs. Those shoulders are one reason a bear can pull apart a stump, roll a stone, tear into a termite mound, or dig a winter den. The front of the body became a working tool. A bear paw may look soft when it lands on moss, but inside it are thick bones, tendons, and muscles built for force. The skull changed as well. A broader skull gives more room for jaw muscles. Those muscles help the animal bite, chew, crush, and grind. This mattered because bear diets became flexible. A cat's skull is shaped for gripping prey and slicing meat with sharp cheek teeth. A wolf's body is shaped for steady travel, group hunting, and long pursuit across open land. The bear line moved toward a wider way of feeding. Many bears could eat animal flesh when it was available, then turn to berries, roots, nuts, fish, eggs, insects, or tender plants when those foods were more useful. This mixed diet shaped the teeth. Modern bears usually have strong canine teeth at the front for gripping. Farther back, the molars are broader than the blade-like teeth of a cat. Those flatter molars help with crushing plant material and grinding tougher foods. The teeth tell the story quietly. They show an animal that could still be dangerous while also depending on the slow work of chewing through seasonal food. Even the way a bear walks is part of this older design. A bear places the full sole of each foot on the ground. That plantigrade stance gives stability under a heavy body. It also helps when climbing, digging, wrestling with food, or standing upright to smell the air. Speed still matters for short bursts, and some bears can run faster than many people expect. Their main advantage grew from strength, balance, and endurance through difficult seasons. Across millions of years, these changes gathered into the shape we know. The small forest carnivore gave way to an animal with heavier bones, stronger shoulders, a broader head, and a body able to turn many foods into stored energy. The bear became a calorie seeker, a reader of seasons, a patient mover through changing ground. Such a body only becomes powerful when the world gives it enough places to work. Forests, rivers, mountains, coastlines, grasslands, and frozen shores each tested the bear shape in a different way. As the bear family spread, that same basic body began to answer many landscapes at once. That same body moved into many kinds of places. The bear shape entered forests, mountains, river valleys, coastlines, tropical woods, bamboo hills, and Arctic ice. Across time, the family spread through North America, South America, Europe, and Asia. Each place asked something different from the animal. A bear in a cold northern forest needed to find food during short summers and survive long winters. A bear near the ocean could follow fish, shellfish, or sea mammals. A bear in tropical forest had to handle heat, thick plants, insects, fruit, and trees full of hidden food. The same broad body plan kept changing its habits as the ground changed beneath it. Brown bears became one of the widest-ranging examples. Their scientific name is Ursus arctos. They have lived across much of the northern hemisphere, from Alaska and western Canada to parts of Europe and Asia. In coastal Alaska, a brown bear may stand in a river during a salmon run, waiting for fish that have returned from the Pacific Ocean to spawn. In the mountains of Europe, another brown bear may spend more time feeding on roots, berries, insects, and carrion. The animal is the same species, yet the menu can shift with the land. American black bears, Ursus americanus, tell a quieter forest story. They live across much of North America, from Canada down into parts of Mexico. Many are strong climbers, especially when young. A black bear can use trees for safety, rest, and access to food. In autumn, it may feed on acorns, beech nuts, berries, and insects, building fat before winter. The forest becomes a pantry that changes month by month. Polar bears took the bear body in a colder and more specialized direction. Their scientific name is Ursus maritimus, meaning maritime bear or sea bear. They live around the Arctic, where sea ice forms over ocean water. Their main prey is seal, especially ringed seals, which they hunt from the ice. A polar bear may wait near a breathing hole, where a seal must surface for air. Its large paws help spread its weight over snow and ice, and thick fur with a dense layer of fat helps it stay warm in freezing conditions. Here, the bear body became tied to frozen ocean. Far away from Arctic ice, giant pandas became shaped by bamboo forests in central China. A panda belongs to the bear family, even though its daily life looks very different from that of a polar bear. Bamboo is tough, fibrous, and low in energy compared with meat. Because of this, pandas spend many hours each day eating. They also have an enlarged wrist bone that works almost like a thumb, helping them hold bamboo stems while they bite through the stalks and leaves. The bear body, in this case, became a quiet feeder in green mountain forest. Sloth, bears of the Indian subcontinent, followed another path. They feed heavily on termites and ants. Their long, shaggy fur, pale chest mark, flexible lips, and strong claws all fit a life of tearing into insect nests. A sloth bear can blow dust away and suck insects into its mouth with a loud feeding sound. Its front teeth leave a gap that helps with this suction. The same basic bear ancestry found a way to live on tiny insects hidden inside hard earthen mounds. In the tropical forests of Southeast Asia, the sun bear became the smallest living bear. It has short black fur, a pale chest patch, long claws, and a very long tongue that can help it reach honey and insects. Sun bears climb well, and their world is often vertical. Food may be under bark, inside logs, in fruiting trees, or inside bee nests. In South America, the spectacled bear lives along the Andes. It is the only living bear native to that continent. Its pale face markings can look like glasses, which gives it the name spectacled bear. It feeds on fruits, bromeliads, cactus, and other plants, often climbing trees to build feeding platforms. Seen together, these bears show how far one family can stretch. A seal hunter on sea ice, a bamboo feeder in misty mountains, a termite eater in dry forest, a fruit seeker in the Andes, a salmon catcher in cold rivers, a tree climber in North American woods. The bear body did not become a single answer. It became a set of possibilities. carried into different regions by time, climate, hunger, and chance. Each living species now feels like its own quiet experiment. The outline remains familiar. The life inside it keeps changing. Across all those places, the bear family has narrowed to 8 living species. Each one carries a different life, yet the family resemblance remains easy to feel. The American black bear moves through oak forests, pine woods, swamps, and mountain slopes across much of North America. The brown bear ranges through parts of North America, Europe, and Asia, with coastal bears in Alaska sometimes growing much larger than inland bears because salmon can provide so many calories. Polar bears live around the Arctic Ocean, where their lives depend on sea ice and the seals that surface through breathing holes. The Asiatic black bear, sometimes called the moon bear, lives across parts of Asia and often has a pale crescent mark on the chest. South America has the spectacled bear, an Andean species with light markings around the eyes and face. In the forests of India, Nepal, and Sri Lanka, the sloth bear searches for ants, termites, fruits, and honey. Southeast Asia holds the sun bear, the smallest living bear with short dark fur and a long tongue useful for reaching insects and honey. Central China holds the giant panda, a bear whose whole daily rhythm is shaped around bamboo. Seen together, these animals seem almost too different to belong to one family. A polar bear may cross white ice with black skin, hidden under clear-looking fur. A sun bear may climb through humid forest, where the air feels warm and heavy. A panda may sit among green stems for hours, stripping bamboo with slow, steady bites. Yet the ancient bear outline still shows through. Bears usually have heavy bodies. Their tails are short. Their limbs are strong. Their paws are large. Their jaws can apply serious force. Those shared traits form the ursid blueprint. A blueprint is a basic design that can be changed for different uses, while keeping the same deeper plan. In bears, that plan includes a large head, rounded ears, a sturdy body, and feet that rest flat on the ground. Most bears also have 5 toes on each foot, with claws that stay out rather than sliding back like a cat's claws. The claws are useful working tools. They help with digging, climbing, gripping, tearing into logs, breaking open insect nests, and moving across snow or soil. The teeth also show the old bear pattern. At the front of the mouth, large canine teeth can grip and hold. Farther back, broad molars can crush and grind. This mix helps many bears live on a wide range of food. The same mouth that can handle meat at bay can also work through berries, acorns, roots, grasses, insects, or tough plant parts. Polar bears carry this design toward marine hunting. Their long necks and narrow skulls help them reach into seal breathing holes. Large paws spread weight across snow and work like paddles in cold water. Their diet can be rich in seal fat, which matters in the Arctic because fat stores more than twice as much energy per gram as protein or carbohydrate. Giant pandas carry the bear body in a very different direction. A panda still has the skull, paws, and heavy build of a bear, yet it eats mostly bamboo. Bamboo is fibrous and low in easy energy, so pandas often feed for many hours a day. Their famous false thumb is actually an enlarged wrist bone, called the radial sesamoid. It presses against the paw like a small extra grip, helping the panda hold bamboo stems while the teeth peel and crush. Sloth bears show a different use of the same family plan. Long claws help them rip open termite mounds. Flexible lips and a gap in the front teeth help them suck insects from tunnels. This makes their feeding sound loud and distinctive, like air being pulled through a narrow tube. Sun bears take the bear form into tropical climbing and foraging. Their claws are long and curved. Their bodies are compact. Their tongues can reach into small spaces where honey, beetle larvae, or termites may be hidden. Each species stretches the same old design toward a different kind of food. Sea ice, bamboo forest, termite mound, fruiting tree, salmon river, and mountain slope all shape what a bear becomes. The differences are easy to notice first. The shared machinery waits underneath. A bear body is a strong, flexible system, and its parts begin to make more sense when we slow down and look at what they are built to do. A bear body begins with weight meeting the ground. When a bear walks, it places the full sole of each foot against the earth. The heel comes down, the broad pad spreads, the toes press forward. This kind of walking is called plantigrade walking, which simply means walking on the whole foot. Humans walk this way too. So do raccoons and some other mammals. Cats and dogs usually move higher on their toes, which gives them a lighter, springier step. A bear's step feels more grounded. Each footfall carries the body like a heavy platform moving across soil, snow, rock, or forest leaves. This helps explain why a bear track can look so clear in mud. The back foot may leave a long print, with the heel visible behind the toes. In soft ground, a large brown bear track can be wider than a human hand. On snow, the same foot spreads weight more evenly, helping the animal cross drifts, riverbanks, and frozen slopes. That solid footing supports the rest of the body. A bear's legs are strong, yet the front half of the body carries special power. The shoulders are thick because the muscles there do a great deal of work. A bear uses its forelimbs to dig into soil, pull apart rotten logs, climb trees, move stones, scrape bark, break into insect nests, and open hidden food sources. In some species, the shoulder hump is especially visible. A grizzly bear has a high mound of muscle over the shoulders, giving the front of the body a raised, powerful shape. That hump helps drive the forelegs when the animal digs. In dry ground, a grizzly can move earth with surprising force. In mountain meadows, it may dig for roots, ground squirrels, bulbs, or insects buried below the surface. The same front-heavy strength helps a bear turn objects that would stop many other animals. A fallen log can become a meal. Under the bark, beetle larvae may be hidden. Inside the soft wood, ants may be moving through tunnels. A bear can hook its claws into the surface and pull the whole thing apart, exposing food that was sealed away from the open air. Those claws are built like working tools. A cat's claws can slide back into protective sheaths. A bear's claws stay exposed. They are always present at the ends of the toes, touching the ground, catching on bark, scraping soil, and wearing down slowly through use. The shape of the claws differs between species. Black bears often have shorter, more curved claws that help them climb. A young black bear can scramble up a tree with quick, gripping movements, using claws like hooks in the bark. Grizzly claws are usually longer and straighter. They can be several inches long, better suited for digging than fine climbing. Polar bear claws are shorter and sharp, useful for gripping ice and holding prey on a slippery surface. The paw itself is also sensitive. Beneath the thick pads are nerves that help the animal feel pressure and texture. A bear walking through a river can sense stone, mud, water movement, and balance through its feet. This matters because power alone would be wasteful without control. The body has to place weight carefully. A large bear can cross a narrow log, climb a slope, or step over cubs with quiet precision. The jaws add another kind of strength. Bears have large canine teeth at the front of the mouth, useful for gripping. Farther back, the cheek teeth can crush and grind. In many species, this mixed tooth pattern fits a life of varied food. A bear may tear flesh during one season and chew acorns or berries in another. The skull gives room for muscles that close the jaws with force, while the neck and shoulders help anchor the head during pulling, biting, and lifting. All of this makes the bear seem powerful from the outside. The paws, claws, shoulders, skull, and heavy walk all show strength in visible ways. Yet much of a bear's success begins before the body takes action. Long before a paw breaks a log or a jaw closes around food, the animal may already know something is there. The air carries messages. The ground holds traces. A bear's next movement often begins with scent. Scent reaches the bear before the visible world does. A log may look ordinary. A patch of grass may seem empty. A breeze may pass through spruce needles with no message a person can understand. For a bear, the air is full of information. A bear's nose is one of the most important tools it has. Inside the snout are folded surfaces covered with scent receptors, the tiny cells that detect odor molecules. Those folds create more room for smell-sensitive tissue than a smooth inner nose could hold. When a bear lifts its head and draws in air, it is sampling traces left by food, water, animals, plants, and other bears. A human may look across a forest and notice trunks, shadows, leaves, and a narrow trail. A bear may notice something else entirely. A berry patch ripening somewhere beyond the trees, a dead animal hidden behind brush, a salmon stream carrying oily traces through damp air, a female bear that passed through hours earlier, a cub nearby, a campsite where someone left food in a cooler or crumbs beside a fire ring. Scent turns the landscape into a layered map. Some odors are fresh and sharp. Others are faint, old, and broken apart by wind or rain. Warm air can lift smells upward. Cold air can hold them close to the ground. Moist air often carries scent better than dry air, which is why a bear moving after rain may be reading a richer world than one moving through dusty heat. Wind direction matters too. A bear may pause with its nose pointed into the breeze, letting the air bring the forest toward it. This is one reason bears often appear still before they move. The stillness is useful. The animal is gathering detail. A carcass may be out of sight, but its odor can spread long before the body is visible. For a scavenging bear, that can mean a large meal. A dead deer, elk, moose, or marine mammal can provide fat and protein with less effort than chasing live prey. In spring, when a bear emerges from winter with reduced stores, that kind of food can matter greatly. The nose can also guide a bear toward plants. Berries do not ripen all at once across a whole landscape. Blueberries, huckleberries, salmonberries, and elderberries follow local timing shaped by sun, slope, elevation, and weather. A hillside facing the sun may ripen earlier than a shaded valley. A bear that remembers old feeding sites and can smell fruit in the air has a better chance of arriving when the calories are ready. That same power can bring bears into danger around people. Human food carries strong odors. Grease, garbage, pet food, birdseed, barbecue scraps, and sweet drinks can drift far from a house, tent, or picnic area. To a bear, those smells may register as concentrated energy. The animal does not need to understand a kitchen, a truck bed, or a garbage bin. It only needs to learn that a certain smell leads to calories. After that lesson, the memory can last. Scent also shapes bear communication. Bears rub against trees, bite bark, step in old tracks, and leave body odors behind. Some marking trees are used again and again. A bear standing on its hind legs to rub its back against bark may be leaving information for other bears that pass later. The message can carry identity, breeding condition, size, or recent presence. A trail through the woods becomes more than a path. It becomes a quiet notice board written in smell. For a mother bear, scent helps keep cubs close. For a cub, the mother's odor is part of safety. In thick brush, where sight may be blocked after only a few feet, smell helps hold the family together. A cub may hear soft sounds, feel movement nearby, and follow the scent of fur, milk, and familiar body warmth. Human beings often trust the visible scene first. We look for movement. We read shapes. We follow color and light. The bear lives in a world where the invisible can be more useful. Food may be hidden underground. A salmon stream may be beyond a ridge. Another bear may have passed in darkness. A den site may hold old traces under snow and soil. Every breath can add a little more to the map. Once the world is understood this way, feeding no longer feels random. The bear is following signs through time. A scent in spring. A fruiting slope in summer. A river in late season. A forest floor heavy with nuts before winter. The nose leads the body toward the calories that keep it alive. The nose leads the bear toward food, and food is the quiet center of almost everything a bear does. Most bears are omnivores. An omnivore is an animal that can eat both plant food and animal food. For a bear, this does not mean every meal looks balanced or planned. It means the body can use many kinds of calories when the land offers them. A black bear in spring may feed on fresh green plants just after the snow melts. Those young shoots are soft, moist, and easier to digest than older leaves later in the year. The same bear may turn over rocks for ants, tear into logs for beetle larvae, climb for cherries, or spend late summer in berry patches where huckleberries and blueberries stain the mouth. In autumn, acorns and beech nuts can become especially important. They are dense foods full of fat and starch. And a forest with a strong nut crop can help a bear gain weight before winter. Brown bears follow an even wider menu in many places. In Yellowstone, a brown bear may dig for roots, feed on army cutworm moths in high mountain talus slopes, take elk calves when they are vulnerable, or search for carcasses left after winter. Along the coast of Alaska, brown bears may gather at salmon streams where fish return from the ocean, with bodies rich in fat and protein. A single landscape can feed a bear in many different ways across 1 year. The bear has to know when each door opens. Polar bears show how far the bear family can lean toward meat. Their lives are tied to Arctic sea ice because seals use that ice to rest, breed, and breathe. A polar bear may wait beside a seal breathing hole for long periods, staying almost motionless in cold wind. Seal blubber is rich in fat, and fat matters deeply in an environment where warmth and energy are expensive. Compared with most bears, the polar bear lives closer to the life of a true predator. Its body is still a bear body, yet its world pushes it toward marine hunting. The giant panda shows the other extreme. A panda eats mostly bamboo, even though its digestive system still resembles that of a carnivore more than a grazing animal. Bamboo contains a lot of tough fiber and gives relatively little energy. Because of this, pandas may spend much of the day eating, often taking in many pounds of stems and leaves. Their enlarged wrist bone helps grip bamboo, while strong jaw muscles help crush the stalks. The panda's life is a reminder that a bear body can become deeply tied to one plant, even while carrying the ancestry of meat-eating mammals. Sloth bears follow insects. They use long claws to break open termite mounds and ant nests. Their lips can move forward, and the gap in their front teeth helps them pull insects into the mouth. This feeding style is so specialized that a sloth bear can sound almost like a vacuum as it eats. Sun bears in Southeast Asia often search for honey, fruit, termites, and beetle larvae inside warm tropical forests. A long tongue helps them reach into narrow spaces. Their compact bodies and curved claws help them climb after food above the ground. These differences reveal the main gift of the bear family: flexibility. A wolf pack may depend heavily on prey. A cat may be shaped around stalking and killing. Many bears can shift with the season. When fruit ripens, they feed on fruit. When fish arrive, they feed on fish. When insects are available, they dig and tear and lick. When a carcass appears, they may follow the scent and claim the calories before another animal does. This flexibility gives bears a wide margin for survival, yet it also gives them a constant burden. A bear cannot drift through the year and hope winter will be kind. Its body is large. Large bodies need large amounts of energy. Every berry, salmon, grub, root, nut, and strip of fat becomes part of a larger seasonal account. The land gives food in waves. Spring opens softly. Summer fills the edges. Autumn becomes urgent, even when the forest looks calm. A bear feeding in golden leaves is already living ahead of the cold. The search for food is becoming the search for stored time. The search for stored time follows a calendar. For many bears, the year is shaped less by dates on a page than by snow, thaw, flowers, insects, berries, fish, and frost. A bear waking in spring enters the leanest part of its year. In northern forests, the ground may still be frozen in patches. Old snow can linger in shaded gullies. Grass is only beginning to rise along riverbanks and open slopes. A bear that has spent months in a den may have lost a large amount of body weight, sometimes hundreds of pounds in large brown bears. Its first meals may be small compared with what comes later. Fresh sedges, tender shoots, winter-killed animals, roots loosened from damp soil, ants under stones once the ground warms. Spring food often arrives slowly. The bear moves through a world that is waking up piece by piece. A south-facing hillside may turn green before a shaded valley. A river edge may offer new plants before the forest floor does. This is why timing matters so much. Strength helps a bear dig, climb, and defend food. Timing tells it where that food will be. By early summer, the land begins to offer more. Insects become active. Leaves expand. Flowers turn into early fruit. Deer, elk, or moose calves may be born in some regions, creating a brief window when young animals are small and vulnerable. A bear does not need every food source to last long. It needs to meet each one at the right moment. The year becomes a moving pattern. When one food fades, another may begin. By late summer, berries can become one of the great quiet feasts of bear country. In parts of western North America, huckleberries, blueberries, buffalo berries, and salmon berries can draw bears to hillsides, meadows, and forest edges. A bear may feed for hours, pulling fruit from low shrubs with lips and teeth. Each berry is small, yet thousands of berries can become a serious meal. The animal's body is already changing during this time. Appetite grows. Feeding time expands. Movement becomes more focused around high-calorie places. This period is often called hyperphagia, a word that means extreme eating. During hyperphagia, a bear may spend much of the day searching for food and consuming it. The body is preparing for winter long before winter has arrived. Autumn carries a different feeling. The light lowers. Nights cool. Nuts begin to drop in hardwood forests. Acorns from oaks and beech nuts from beech trees can become vital foods for black bears in eastern North America. These nuts hold fat and starch in a compact form. A strong nut year can help bears gain weight quickly. A poor nut year can push them to travel farther, search harder, and sometimes move closer to farms, towns, or backyards. In salmon country, autumn can bring another kind of abundance. Fish returning from the ocean carry marine nutrients inland. A brown bear standing in cold water may be taking energy from the sea and storing it inside a body that will soon withdraw into the quiet of winter. In many northern habitats, the difference between abundance and scarcity is sharp. A summer slope can hum with insects and hang with fruit. Months later, the same slope may be locked under snow. The bear survives because its body treats the good season as preparation. Calories become fat under the skin and around organs. Fat stores energy, helps insulate the body, and supports the long fast that may come. When winter nears, the bear's choices grow more careful. A wasted chase costs energy. A dangerous fight can bring injury at the worst possible time. A poor feeding route may mean too many miles for too little reward. The bear has to balance effort against return. Foraging, hunting, resting, and moving all become part of the same quiet calculation. The calendar of hunger teaches the bear to follow the land without forcing it. A green edge in spring. A berry slope in summer. a nut grove in autumn, a den site before deep cold. Survival depends on reading these changes with the body, the nose, and memory. The bear moves through the year as if listening to a slow song of food appearing and fading. To endure that song, it must know when to search, when to wait, when to take a chance, and when stillness saves more life than motion. Stillness can save a bear more energy than speed. A cheetah is shaped for a short burst across open ground, with a light frame, long legs, and a flexible spine that helps it stretch through each stride. A wolf is shaped for distance, able to travel in a pack and keep pressure on prey over many miles. A bear carries a different kind of hunting body. It can move quickly for a short distance, and a large bear can run faster than many people expect. Yet its deeper advantage comes from strength, smell, patience, and choosing the right moment. A heavy body costs energy to move. Every chase has a price. For an animal trying to build fat before winter, wasted effort can matter. A bear has to measure the world in calories gained and calories spent, even without thinking in human numbers. A rotten log full of beetle larvae may be worth more than a hard chase through trees. A salmon trapped in shallow water may offer more than a long pursuit of a healthy deer. A carcass found by scent may provide a meal with far less effort than catching live prey. This is why bear hunting often looks quiet from the outside. A brown bear may move slowly along the edge of a meadow, using wind to carry scent from hidden animals. In spring, young elk or moose calves can be vulnerable during their first days of life. They are small, unsteady, and often hidden in grass or brush. A bear searching with its nose may find what the eye would miss. Terrain matters here. Dense willow thickets, river bends, steep slopes, snow patches, and forest edges can all shape the chances of a hunt. The bear does not need open speed when cover, scent, and surprise are enough. Black bears also take animal prey when the chance appears, especially young ungulates in spring, insects in summer, or carrion after winter. Much of their year still depends on plants, nuts, berries, and insects. Their hunting fits inside a wider life of mixed feeding. They may climb for safety, dig for roots, tear into logs, or follow the smell of a dead animal through the woods. The same animal that can be dangerous to prey may spend hours picking fruit from shrubs. That mixture is part of the bear's success. Polar bears show the sharper predator side of the family. On Arctic sea ice, the main prize is often a seal. Ringed seals keep breathing holes open in the ice so they can surface for air. A polar bear may wait beside one of these holes for a long time, sometimes lowering its body close to the ice and staying nearly motionless. The hunt depends on patience and timing. When a seal surfaces, the bear uses sudden force at very close range. This style of hunting suits the Arctic because the ice itself controls where prey must appear. A seal hidden under water still has to breathe. The bear's task is to find the right place and wait. Polar bears also search near seal birth lairs, where seals make snow-covered shelters on top of the ice. They may use smell to detect a hidden lair beneath snow. In that frozen world, the nose can locate life under a surface that looks blank. The white landscape becomes a field of faint traces, pressure points, and openings. A polar bear walking across sea ice is hunting through geography as much as through motion. Energy is central again. Seal fat is rich fuel. For a large Arctic predator, one successful hunt can matter far more than many failed movements. This is especially important because polar bears may go long periods between meals. The ice, the wind, the seal breathing holes, and the bear's patience all meet in a slow calculation. Many bear hunts follow this same quiet rule. Opportunity carries value. A fish in shallow water, a nest of insects under soil, a young animal hidden in grass, a carcass under trees, a seal surfacing through ice. The bear works with what the land offers. Its power is real, but power alone would burn too much energy if it were used without care. The best meal is often the one found at the right moment, in the right place, with the least waste. That is why the most dramatic feeding in bear life often comes when the landscape itself gathers food into one place. A river can fill with salmon. A slope can ripen with berries. A forest can drop nuts across the ground. For a bear, these rare windows can shape the whole year. A river can turn hunger into abundance. In Alaska's Katmai National Park and Preserve, brown bears gather where salmon return from the sea. Katmai lies on the Alaska Peninsula, a wild region of volcanoes, lakes, tundra, and cold rivers that drain toward Bristol Bay and the Pacific side of the peninsula. One of its most famous places is Brooks River. The river is short, only about 1.5 miles long, connecting Brooks Lake to Naknek Lake. Yet during salmon season, that small stretch of water can become one of the most important feeding places in a bear's year. Sockeye salmon return there after living in the ocean. They travel back into fresh water to spawn, which means to lay eggs and create the next generation. Their bodies carry energy gathered from years at sea. When the salmon push upstream, the river becomes crowded with movement. Silver and red bodies hold against the current. Some gather below small waterfalls. Others move through shallow gravel beds where the water is clear enough to see stones on the bottom. For a bear, this is a rare gift. Food has gathered in one narrow place. The animal no longer has to search across miles of forest for scattered berries or insects. It can stand in the water and let the season come toward it. A large brown bear may eat dozens of salmon in a day when fish are abundant. The exact number depends on the bear, the river, the fish, and the stage of the season. During peak feeding, the goal is simple inside the body. Take in more energy than the day costs. A sockeye salmon can contain valuable protein and fat, especially before spawning has drained its reserves. In early runs, the fish are often richer. Later, after they have spent more energy moving upstream and reproducing, their bodies become leaner. Bears seem to respond to this difference. When salmon are plentiful, they may choose the richest parts. A bear may eat the skin, the fat, the brain, or the eggs, while leaving much of the rest behind. This can look wasteful to human eyes. Inside the bear's seasonal math, it makes sense. Fat holds more energy than lean flesh. Eggs can be rich in nutrients. When time is limited and salmon are many, choosing the densest calories helps the bear build reserves faster. The river also reveals bear society. Brown bears often live alone across much of the year, yet salmon streams can bring several bears into view at once. They do not all feed in the same way. large adult males may claim the best fishing spots, especially places where salmon are forced to leap or slow down. At Brooks Falls, bears can stand near the falling water and wait as salmon try to jump upward. A more experienced bear may hold a position that gives it repeated chances with little movement. Younger bears, smaller bears, or mothers with cubs may feed farther downstream or along quieter edges. The river becomes a map of size, age, confidence, memory, and risk. A bear that knows the river well may understand where salmon pause. It may remember which channel runs shallow in late summer. It may know which bank offers space away from larger rivals. Physical condition matters too. A bear arriving thin after a difficult season has more urgency. A heavy bear with strong fat reserves may have more freedom to rest between meals. Mothers with cubs face a different pressure because cubs must be kept away from danger while the family still gathers food. The sound of the river softens the scene. Water moves over stones. Salmon hold in the current. A bear stands with wet fur darkened along the legs. Every small action has weight behind it. A step into the right channel. A pause before a strike. A turn of the head toward another bear. A choice to stay, shift, or leave. The salmon run carries ocean energy into the body of a land animal. That energy will soon become something quieter. Under the skin, it becomes fat. Around organs, it becomes stored fuel. Across the bear's back and sides, it becomes the difference between a hard winter and a survivable one. The feast at the river is dramatic because the water is alive with movement. Its deeper meaning is hidden in the body. The bear is storing a season inside itself. The salmon, the berries, the acorns, and the insects all begin to disappear into one quiet place. They become part of the bear. Under the skin, around the organs, and across the thick body wall. The food of summer and autumn is stored as fat. To human eyes, fat often looks like simple weight. In a bear, it is a survival system. Fat is one of the richest fuels a body can carry. 1 gram of fat holds about 9 calories of energy, while 1 gram of protein or carbohydrate holds about 4. That difference matters for an animal that may spend months inside a den without eating. A bear that builds fat well in autumn is carrying a dense store of energy into winter. Every salmon skin, every acorn, every mouthful of huckleberries, every insect pulled from rotten wood, all of it can become part of the reserve that keeps the heart beating when the forest is cold and still. During late summer and autumn, many bears enter a state called hyperphagia. The word means extreme eating. A bear in this period may feed for many hours a day, moving from one rich food source to another. In coastal Alaska, brown bears can grow visibly round before winter. At Katmai, people often notice how different the same bear can look from early summer to autumn. A leaner animal in June may become broad, heavy, and thick by September. The body is preparing before the snow arrives. Fat also helps with warmth. A layer of fat beneath the skin slows the loss of body heat. This matters in a den where the air can stay cold for weeks. Fur traps air close to the body, and fat helps hold warmth deeper inside. The bear's winter shelter may be dug into a hillside. tucked under tree roots, hidden beneath snow, or placed in a natural hollow. Inside that space, the body draws slowly from what it stored. Fat becomes fuel for the brain, heart, muscles, and organs. It also becomes water. When fat is broken down through metabolism, which means the chemical work cells use to release energy, it produces a small amount of water inside the body. This is called metabolic water. Desert animals use the same basic process. So do hibernating bears. A bear in a den may go for months without drinking from a stream or eating snow. Part of its water supply is made quietly as stored fat is used. The den becomes a closed world. Outside, branches crack under ice. Rivers slow beneath snow bridges. Berries are gone. Insects are sealed under bark or frozen soil. Inside, the bear's body is using autumn as carefully as a lamp uses oil. The stored fat must last through the long pause. It must support the animal while the heart rate slows. It must help maintain body temperature. For pregnant females, it must also support the growth of cubs and the production of milk. That makes fat especially important for mothers. Bear cubs are usually born during the denning period, tiny and helpless, compared with the size of the adult female. The mother does not leave to feed. Her body turns stored energy into milk, while she remains hidden in the dark. The fat gathered before winter becomes warmth for her, and nourishment for the cubs pressed against her body. This is why autumn feeding carries such quiet urgency. A bear moving through a nut grove or standing in a salmon river is preparing for events that may happen months later. The body is solving winter before winter fully begins. A poor food year can ripple forward into survival, birth, cub growth, and spring condition. A rich food year can give a bear more strength to endure the cold months and emerge with enough reserves to begin again. Fat holds more than energy. It holds time. It holds the memory of rivers, forests, roots, and fruiting slopes inside living tissue. Once the storehouse is full enough, the bear can do something astonishing for such a large animal. It can withdraw from the visible world. The tracks grow fewer. The feeding stops. Somewhere under snow, soil, roots, or stone, the body begins to live from what it has already gathered. The tracks begin to fade as winter takes hold. A bear that spent autumn feeding along rivers, hillsides, and forest floors starts looking for a place where the body can withdraw. In cold regions, the den may be dug into a steep slope where snow will later cover the entrance. Some bears use hollow trees, root tangles, caves, rock shelters, brush piles, or spaces under fallen logs. A black bear in an eastern forest might settle inside a tree cavity lined with leaves. A brown bear in Alaska may dig into a hillside above a valley, where drifting snow helps seal the entrance. In mountain country, a den might sit on a sheltered slope where wind passes over the surface while the animal rests below. The den does not need to be beautiful. It needs to be protected. A narrow entrance helps hold warmth. Packed snow can act like insulation, trapping air pockets that slow heat loss. Dry leaves, grass, moss, or shredded wood may form a rough bed beneath the body. The space is often just large enough for the bear to curl, shift, breathe, and wait through the coldest part of the year. Outside, winter keeps simplifying the world. Berries are gone. Ants and beetles are hidden under frozen soil or bark. Salmon streams may run cold and empty. Nut crops have been eaten, buried, or covered. In many northern places, snow turns the ground into a quiet white surface, where food is hard to reach and movement costs more energy. Inside the den, the bear becomes a closed system. It may go for months without eating. It may go for months without drinking. It may also avoid urinating or defecating through much of the denning period. For a large mammal, this is astonishing. Most active animals must take in food, release waste, and drink regularly to keep the body stable. A bear in winter is living from the storehouse it built earlier. The fat under its skin is slowly broken down to release energy. That same fat helps make metabolic water, the water produced inside the body when stored fuel is used. The bear's heart rate slows. Its breathing becomes slower. Its metabolism drops, meaning the chemical work of the body becomes much less active. The body is still alive, warm, and responsive, but it is spending energy with great care. A bear can still wake if disturbed. This makes bear hibernation different from the deep, cold torpor seen in many small animals. Torpor is a state where body activity drops sharply to save energy. Small hibernators, such as ground squirrels, may let their body temperature fall close to the temperature around them. Bears usually keep a much warmer body than that. Their temperature drops only moderately, while their energy use falls in a remarkable way. That balance allows the animal to stay ready enough to respond, especially mothers with newborn cubs. The den is quiet, but the body is busy in hidden ways. Waste products are managed instead of simply building up. Water is conserved. Muscle is protected far better than it would be in a human lying still for the same length of time. Bones also hold their strength with surprising success. A person confined to bed for months can lose muscle and bone density. The bear rests through winter and still has to rise in spring, walk out, search for food, and survive. This is the deeper mystery of the den. From the outside, the bear seems to vanish. No feeding trails, no fishing posture in the river, no broad back moving through berries, only a mound of snow, a dark hollow, or a hidden space beneath roots. Inside, the animal is not gone from the world. It has turned inward. The body is rationing autumn. The heart is slowing without stopping. The muscles are waiting without wasting away. The bear has entered a season where survival depends on keeping almost everything inside. Inside the den, the bear's body enters a state that looks quiet from the outside and highly organized within. The heart slows, breathing softens, energy use falls. For a large bear, the change can be dramatic. During the active months, a bear's heart may beat dozens of times each minute as it walks, feeds, climbs, digs, and swims. During hibernation, that heart rate can fall to only a small fraction of its usual pace. Some bears may drop to fewer than 10 beats per minute during deep rest. The whole body begins spending fuel carefully, like a cabin using a small fire through a long night. Metabolism is the name for the chemical work that keeps a living body running. It includes everything cells do to release energy, repair tissue, move materials, and keep organs alive. In hibernation, a bear lowers that work sharply. Its body uses far less energy than it would during an active winter day. Yet the bear remains much warmer than many smaller hibernating animals. A ground squirrel can let its body temperature fall close to freezing. A bear usually lowers its temperature by only several degrees. This makes bear hibernation unusual. The body saves great amounts of energy while still staying warm enough to wake, move, and respond if danger enters the den. That balance matters for mothers. A female with cubs cannot become completely unreachable. She may shift her body, nurse her young, and react to disturbance while still fasting. The bear is resting deeply, yet the body keeps enough warmth and awareness to protect life in the dark. The kidneys also change their work. Kidneys normally filter the blood and help remove waste through urine. In humans, waste from protein breakdown becomes urea, which is carried in the blood and released through urine. A hibernating bear produces very little urine for long periods. The urea does something remarkable. Instead of being lost from the body, much of it is recycled. Microbes and body processes help turn nitrogen from urea back into building material for proteins. Proteins help maintain muscles, organs, skin, and other tissues. This recycling helps explain why a bear can rest for months and still preserve far more muscle than a human would. A person confined to a hospital bed for weeks can lose strength quickly. Muscles shrink when they are unused. Bones can lose minerals when they no longer carry weight. The human body expects movement. Without it, legs weaken, balance fades, and bone tissue can become thinner. A bear faces months of stillness and emerges with much less damage than expected. Its muscles still need to recover after winter, yet they have avoided the severe wasting that would normally come with such a long fast. Bone preservation is also striking. An inactive human skeleton loses strength because bones respond to pressure and use. Bear bones seem to hold up far better during denning. The body is somehow keeping the internal repair systems active enough to protect structure, while the animal barely moves. Water is managed with the same care. Because the bear is using stored fat, chemical reactions inside the body produce metabolic water. That water helps replace what the animal would otherwise need to drink. Waste is reduced. Fuel is rationed. Organs continue working at a slower pace. The den becomes almost like a sealed laboratory under snow. A living body is solving problems that modern medicine still studies with wonder. Long fasting without starvation damage. Long stillness without extreme muscle loss. Low kidney activity without ordinary waste buildup. A slower heart that keeps the animal alive through cold months. The bear is doing all of this without machines, tubes, monitors, or outside help. Its body learned the pattern through evolution. Season after season, over countless generations, the bears that managed winter best were more likely to survive and raise young. Hibernation, then, is more than sleep. It is controlled survival. A deep winter setting, where the body lowers its demands while protecting what it will need in spring. When the bear finally rises, the mystery follows it out of the den. The same animal that rested for months must walk, search, climb, feed, and begin again. That difference between the bear body and the human body turns winter rest into something larger than a wildlife fact. It becomes a medical puzzle hidden inside fur, fat, breath, and snow. The bear leaves the den carrying a mystery that reaches far beyond the forest. For months, its body has rested in darkness. The legs have barely moved. The heart has slowed. Food and water have stayed outside the den. A human body placed under those same conditions would face serious trouble. After only a few weeks in bed, people can lose muscle strength, balance, and bone density. Bone density means how much mineral strength is packed into the skeleton. When bones stop carrying weight, they can begin to thin. Astronauts face a similar problem in space. In orbit, the body floats in microgravity, a condition where weight feels almost absent. Because the legs and spine no longer push against the ground in the usual way, muscles weaken and bones lose minerals. That is why astronauts follow strict exercise routines on the International Space Station. Treadmills, resistance machines, and cycling devices help replace some of the work gravity normally provides. A bear in a den has no treadmill. It has no physical therapy. Its body spends winter curled in a small space under snow, roots, or frozen soil. Even so, it protects itself with remarkable skill. This is why scientists study bear hibernation. The bear offers a living example of long fasting, low movement, slower heart rhythm, and tissue protection in one large mammal. Medical researchers are especially interested in muscle loss. In hospitals, people who stay in bed for a long time can become weak very quickly. This can happen after surgery, serious illness, injury, or time in intensive care. Intensive care is the part of a hospital where very sick patients receive close support, often with machines helping the body breathe, filter blood, or maintain stable conditions. The longer a person remains still, the harder recovery can become. A bear shows that mammal muscle can be preserved under extreme stillness if the body has the right chemical controls. Those controls may involve changes in hormones, recycled nitrogen from urea, and signals that tell muscle cells to slow their breakdown. Kidney function is another area of interest. Human kidneys filter waste from the blood every day. When they fail, waste and fluid can build up in dangerous ways. During hibernation, a bear's kidneys greatly reduce their output. Yet the animal avoids the kind of poisoning that would harm a person. Urea, a waste product made when protein breaks down, is recycled instead of being released through urine. Some of its nitrogen can be used to help build new proteins. That process may help maintain muscle and organ tissue during the long winter fast. Metabolism also matters. A human with a very low heart rate and long periods without food would usually need careful medical monitoring. A hibernating bear lowers its energy use in a controlled way. The body slows many processes while still keeping the animal warm enough to wake if needed. Researchers hope this can teach useful lessons about protecting organs during surgery, trauma, long illness, or even future space travel. A patient waiting for recovery and an astronaut traveling far from Earth both face the same basic challenge. The body needs ways to save strength when normal movement becomes limited. Bone protection adds another layer. Human bones respond to pressure. Walking, lifting, and standing tell the skeleton to stay strong. When that pressure disappears, bone can weaken. Bears spend months with little movement, yet their skeletons appear to resist much of this seasonal damage. Something inside their winter biology seems to keep bone recycling in balance. The body is still breaking down and rebuilding tissue, only at a slower and more careful pace. The bear is not a direct medical answer. A person cannot copy hibernation by sleeping longer or eating differently. The value comes from studying the hidden controls. Which signals protect muscle? Which chemical pathways recycle waste? Which changes slow metabolism safely? Which processes hold bone strength during stillness? The den becomes a natural model for problems humans are still trying to solve. A large mammal pauses through winter and rises again with its body mostly intact. That alone would be remarkable. Yet in the deepest part of this slow season, another event can unfold beneath the snow. Inside the same dark shelter where the mother has eaten nothing for months, new life may begin breathing for the first time. Inside the winter den, the quiet can hold more than survival. For some bears, it also holds birth. A mother bear may be curled in a hollow beneath snow, roots, or frozen soil while the outside world remains locked in winter. She has not been feeding. She has not walked to a stream for water. Her body is still living from the fat gathered during warmer months. Yet in that hidden space, cubs may arrive. Bear cubs are born astonishingly small compared with their mothers. A newborn black bear cub may weigh less than 1 pound. A newborn brown bear cub is often close to that same tiny size, even though an adult female brown bear can weigh hundreds of pounds. The difference is almost difficult to picture. A mother can be the size of a large piece of furniture. Her cub may be small enough to fit in 2 human hands. The cubs are born blind. Their ears are sealed or barely working. Their bodies have only a light covering of fine fur. They cannot walk, hunt, climb, follow scent trails, or keep themselves warm for long on their own. They enter the world as warm, fragile life, tucked against a body that has already spent months without a meal. The mother's milk becomes their entire world. Bear milk is rich, with high fat content that helps cubs grow quickly during the denning period. The energy for that milk comes from the mother's stored reserves. Salmon, berries, acorns, insects, roots, and fat from earlier meals are transformed inside her body into nourishment for the young. A cub pressed against her belly is feeding from a whole season that happened before it was born. This is part of what makes bear reproduction so carefully timed. In many bear species, mating happens in spring or early summer. Yet the embryo, the earliest form of the developing young, does not always attach to the uterus right away. This process is called delayed implantation. Implantation means the tiny embryo settles into the wall of the uterus so it can begin developing more fully. Delayed implantation means the embryo pauses before that step. The pause can last for months. This allows the mother's body to wait until conditions are right. If she has gained enough fat by autumn, development can continue. If food has been poor and her body is not ready, pregnancy may not proceed in the same way. This timing links birth to survival. Cubs are usually born in the den during winter, often in January or February for many northern bears. By the time spring arrives, the cubs have grown enough to leave the den with their mother. They are still small and vulnerable, but they can move, nurse, and begin learning the outside world. The den gives them a protected beginning. Snow above the entrance can muffle sound. The walls of soil, wood, or packed earth hold the small family in darkness. The mother may shift her position carefully, breathing slowly, listening, nursing, and conserving energy. Her body is balancing two tasks at once. It must keep her alive through the long fast. It must also feed the young with milk made from stored fat. A human mother would need regular food and water to support birth and nursing safely. A bear mother does this while still inside the winter pause. Her body is using the same hibernation system, but with the added cost of new life. This makes the den feel less like an empty shelter and more like a small biological chamber. Waste is managed, water is conserved, milk is produced. Tiny cubs grow in the dark while the outside forest waits for thaw. When the family finally emerges, the cubs enter a world of bright snow, wet soil, broken branches, and unfamiliar smells. Their mother becomes the center of that world. Her body carried them through the den. Her knowledge must carry them through everything after it. A cub begins life with almost no independence at all. Its first real survival system is the mother beside it. The mother is the cub's first shelter after the den. When the family steps into spring light, the cubs are still small. Their legs are short. Their paws look too large for their bodies. Their fur is soft, and their movements can seem unsteady as they follow the larger shape ahead of them. A black bear cub may leave the den weighing only a few pounds. A brown bear cub may also be tiny beside its mother, even after growing through the first weeks of life. The world outside is larger, colder, brighter, and full of smells the cub does not yet understand. The mother moves through it with memory. Her cubs learn by staying close. They follow her through wet grass, over fallen logs, along riverbanks, and into patches of new spring plants. At first, much of their food still comes from milk. Bear milk is rich, and it helps young cubs grow quickly during the early months. Gradually, the cubs begin to taste the world for themselves. They mouth tender plants. They sniff at insects under bark. They watch their mother dig into soil or roll a log aside. A cub does not need a lesson spoken aloud. It learns from the shape of her actions. If she pauses at a berry patch, the cubs pause too. If she climbs, they try to climb. If she rises to smell the air, they learn that scent can carry warning or food from beyond sight. Tree climbing is especially important for young black bears. A cub can scramble up bark with small curved claws, sometimes reaching safety while the mother watches below. High branches can protect cubs from danger, including other bears. The skill begins awkwardly. A cub may slip, cling, adjust, and try again. Over time, the movement becomes quicker and more certain. Play helps build that control. Young bears wrestle, paw at each other, chase, tumble, and bite gently. The play may look careless, but it trains the body. Muscles strengthen. Balance improves. The cub learns how hard it can push, how quickly it can turn, and how another body moves close by. These games prepare the animal for later moments that may carry real risk. Conflict with another bear. A sudden climb up a tree. A quick retreat through brush. A scramble over rocks near a stream. Play also teaches social limits. A cub that bites too hard may be corrected by a sibling or by its mother. Small sounds, body posture, and touch all become part of learning. Even though adult bears are often solitary, cubs begin life in close contact. They sleep against warm bodies. They nurse beside siblings. They test strength in gentle contests. They learn the meaning of distance by staying near the one animal that can protect them. The length of this education varies by species and region. American black bear cubs often remain with their mother for about a year and a half. Brown bear cubs may stay for 2 or even 3 years in some areas. During that time, the mother's home range becomes their first map. A home range is the area an animal regularly uses for food, shelter, travel, and rest. For cubs, it is also a living classroom. One slope may mean roots in spring. A creek may mean insects under stones. A certain hillside may mean berries in late summer. A stand of oak or beech may matter in autumn when nuts fall. A trail may be safe on some days and dangerous on others. The cubs learn these patterns by moving through them with her. They also learn caution. A mother bear may avoid open areas when danger is near. She may steer cubs away from large males. She may choose feeding sites where escape routes are close. Her choices leave marks on the cub's memory. The young bear is slowly building a private map made of scent, taste, fear, comfort, and repeated paths. By the time the family separates, the cub is no longer just carrying instincts. Its body holds learned roots. It senses no familiar places. Its choices have been shaped by months or years beside the mother. The mother eventually walks away, and the young bear must begin reading the land alone. Yet part of her remains in the way it moves. Survival passes through behavior, one remembered path at a time. When the young bear begins moving alone, the forest does not become empty. It becomes quieter. Adult bears are often described as solitary animals. That is mostly true in the simplest sense. A grown bear usually travels, feeds, rests, and dens without a permanent group. There is no pack moving beside it through the trees. There is no herd surrounding it on open ground. Yet a solitary life can still be full of messages. A bear crossing a valley may pass through signs left by others days or weeks earlier. A track in mud can show size, direction, and freshness. A claw mark on bark can show that another bear stood there and reached high. A rubbed tree can hold scent in the rough surface of the trunk. Hair may catch in the bark where a bear pressed its shoulder, neck, back, or flank against the wood. Some trees become used again and again. They stand beside trails, creek crossings, ridgelines, or forest openings. Over time, bark becomes polished. Claw marks rise and overlap. The trunk carries layers of scent from different bears moving through the same area across different seasons. For a bear, this kind of tree can work like a quiet meeting place without a meeting. A male may rub during the breeding season. A female may pass later and investigate. A younger bear may smell the mark and learn that a larger animal has been nearby. The message remains after the body has gone. Scent is especially useful because it lasts longer than sound or sight. A bear can leave information through body odor, urine, droppings, foot scent, and rubbing behavior. The wind, rain, heat, and age of the mark all change how strong the message is. Fresh scent may carry sharply. Older scent may fade into the background of soil, leaves, and wood. The bear reading it does not need language. Its nose gathers the details. Its body responds with caution, interest, avoidance, or curiosity. Tracks can speak in a different way. A wide print in river mud may show that a large adult passed recently. Small prints beside a larger set may show a mother with cubs. Deep impressions can suggest weight. A line of tracks along a stream can reveal a feeding route. Bears read these marks while also leaving new ones behind. Their movements slowly write over the land. Body posture adds another layer when bears meet directly. At a salmon stream, one bear may lower its head, turn sideways, huff, or hold its ground. A larger bear may walk with slow confidence into a fishing spot. A smaller bear may step away before contact ever happens. This kind of communication helps reduce dangerous fights. An injury before winter can cost more than a lost feeding place. Sounds matter too, though bears are often quiet. They can huff, blow air, jaw pop, moan, bawl, growl, or make softer sounds between mothers and cubs. A cub's call can bring the mother's attention quickly. A tense adult may use short bursts of sound as a warning. At food-rich places, these signals become more important because bears are closer together than usual. Brooks River in Alaska is a clear example. During the sockeye salmon run, many brown bears may feed within sight of one another. A strong fishing spot near falling water can attract large adults. Mothers with cubs may choose safer edges. Young bears may wait, shift position, or feed downstream. The river gathers them into a social puzzle created by food. Human places can do the same thing in a more dangerous way. A garbage dump, unsecured dumpster, campsite, orchard, or backyard bird feeder can draw more than one bear into the same area. The food may be easy, concentrated, and strongly scented. The risk rises because bears may cross roads, approach buildings, or meet people at close range. Their social behavior then becomes tied to human mistakes. Solitude, in bear life, carries many quiet signals. A bear may walk alone while still reading a shared world. It smells who passed. It notices where others fed. It remembers where conflict happened. It learns which routes are safe, which trees carry scent, and which places bring reward or danger. Those messages only matter because the bear can hold them over time. The landscape is not just sensed in the moment, it is remembered. Memory turns the bear's world into something deeper than a path. A forest is never only trees to an animal that has lived there for years. It is a pattern of smells, slopes, crossings, feeding places, resting cover, danger, and return. A bear may remember where berries ripened the year before. It may return to the same hillside when the season feels right. In Western North America, huckleberries often grow in open mountain areas, old burns, and sunny forest edges. A bear that knows those places can move toward them in late summer, when the fruit begins turning dark blue or purple. The timing is never perfect from a calendar alone. Elevation matters. Sunlight matters. Rain and heat matter. A patch at lower elevation may ripen before a patch higher on the mountain. The bear's memory helps connect these places into a route, Food appears across the land like scattered islands. A berry slope here, a salmon stream miles away, a stand of oak trees dropping acorns later in the year, a meadow with roots beneath the soil, a place where ants gather under stones. Spatial memory helps the bear link those islands together. Spatial memory means the ability to remember where things are and how to move between them. Humans use it when returning to a familiar house in the dark, or when remembering which road leads to a lake after many months away. Bears use it across much larger and rougher spaces. A black bear may know a patchwork of woods, creeks, fields, ridges, and backyards. A brown bear in mountain country may travel across valleys, river corridors, alpine meadows, and forested slopes. Home ranges can vary widely. In rich habitats, a female black bear may live within a relatively small area. In colder or poorer habitats, a bear may need a much larger range to find enough food. Male bears often roam farther than females, especially during breeding season. Some grizzly bears and polar bears can move across hundreds of square miles, following food, mates, sea ice, or seasonal routes. The memory has to include more than food. A bear may remember where it met a larger bear. It may avoid a narrow trail after a bad encounter. It may learn which riverbank has the best fishing position, which slope melts early, and which den area stays quiet. Cubs begin building this map while following their mother. By the time they separate, many of their first choices have been shaped by her routes. A mother that repeatedly feeds in safe places gives her cubs a starting map of survival. This learning can become powerful around people. Human food is often concentrated, scented, and easy to reach when it is left unsecured. A bear that finds garbage behind a restaurant, grain near a farm, pet food on a porch, or birdseed in a yard may remember the place clearly. The reward can be much easier than digging roots or searching for insects. A cooler at a campsite can hold hundreds or even thousands of calories in one small container. Grease on a grill, fruit fallen under an orchard tree, or feed stored in a shed can pull a bear toward human spaces again and again. This is why wildlife managers often say a fed bear is a bear in danger. The bear has learned something useful by its own rules. The human world turns that lesson into risk. Roads cut across travel routes. Towns sit near rivers and forests. Campgrounds are built in valleys where animals already move. A bear following memory may arrive at a place that once smelled like food and find people, vehicles, lights, dogs, fences, or traps. Its ancient skills still work. The nose still reads the air. The paws still follow the remembered ground. The body still seeks calories before the hard season. The problem is, the landscape has changed faster than bear instinct can change with it. A bear remembering a garbage bin is using the same intelligence that helps it remember a salmon stream. The ability itself is beautiful. The setting can make it dangerous. Memory carries the animal through wilderness, and it also carries it toward the edge of towns, farms, roads, campsites, and backyards, where the old search for food meets the modern human world. That edge between forest memory and human space is where the bear enters our memory too. For as long as people have lived near bears, the animal has been more than a moving shape in the trees. It has been food, danger, rival, teacher, ancestor, spirit, trophy, warning, and symbol. Some of the oldest signs of this relationship are hidden in caves. In Chauvet Cave in southern France, where some paintings are more than 30,000 years old, Ice Age artists painted large animals across limestone walls. The cave also held the marks of cave bears. These were real bears, Ursus spelaeus, animals that lived across Europe during the Ice Age and disappeared around 24,000 years ago. They were close relatives of brown bears, with heavy bodies, high foreheads, and large skulls. Some males may have weighed more than 1,000 pounds. Inside caves, they left claw marks, sleeping hollows, and bones. So when early humans entered those dark chambers with firelight, they were stepping into spaces that bears had already used. The meeting was physical before it became symbolic. People saw the animal's tracks. They saw the size of its skull. They knew the smell of old dens and the risk of meeting a living bear in a narrow place. That closeness helps explain why bears became so important in stories. A bear can rise on its hind feet. It walks with the full sole of the foot on the ground, the same plantigrade posture humans use. Its front paws can pull, hold, dig, and turn objects over. From a distance, a standing bear can look almost human for a moment, until its weight, claws, muzzle, and strength remind the observer what kind of animal is really there. That middle ground gave bears an unusual place in human thought. They were animals of the forest, yet they could seem like powerful neighbors. In northern cultures, bears were often treated with deep respect. Among the Ainu people of Hokkaido in northern Japan, brown bears held major spiritual meaning. In parts of Siberia and northern Europe, people developed careful customs around bear hunting, including songs, feasts, and respectful treatment of the skull or bones. Some Native American traditions also place bears in stories of healing, strength, protection, and transformation. The details differ from culture to culture, and each tradition belongs to its own people. Still, the wider pattern is clear. Where bears lived close to humans, people rarely treated them as ordinary animals. Practical life shaped the relationship too. Bear hides provided warmth. Bear fat could be rendered and used for cooking, lamps, leather care, or medicine. Bear meat fed families in northern winters. Claws and teeth became ornaments in some places. At the same time, bears killed livestock, raided stored food, damaged crops, and frightened travelers. A single animal could be respected in a story and feared near a village. That tension followed humans into modern times. In 1902, United States President Theodore Roosevelt refused to shoot a bear that had been tied up during a hunting trip in Mississippi. The event was turned into a political cartoon, and soon after, toy makers began selling the teddy bear, a wild animal that had once marked cave walls and forest trails, became a soft toy held by children at night. The change is strange, but it shows how strongly bears stay in human imagination. We bring them close even when the living animal needs space. Modern technology has changed the form of the fascination again. At Brooks River in Katmai National Park in Alaska, bear cameras let people watch brown bears catch salmon from far away. Viewers learn the faces, scars, sizes, and habits of individual bears without standing beside the river. Conservation programs add another layer. In the Greater Yellowstone ecosystem, grizzly bears were listed under the Endangered Species Act in 1975 after their numbers had fallen very low. Decades of habitat protection, food storage rules, research, and conflict management helped the population recover. The bear became a subject of radio collars, DNA sampling, den studies, public education, and long legal debates. Human attention can protect a bear, study a bear, name a bear, or turn a bear into a symbol. The living animal still has to find food, avoid roads, raise cubs, and enter winter with enough fat to survive. Admiration by itself leaves garbage cans open, roads busy, and houses built beside travel routes. The old relationship has entered a modern landscape, where the way people arrange food, space, and safety now helps decide whether bears can keep living by the rules their bodies remember. The rules a bear's body remembers can become difficult when the land around it has been rearranged. A bear still follows scent. It still follows hunger. It still follows the places where food once appeared. Human spaces often place powerful smells in small, easy places. A garbage bin behind a house may hold meat scraps, fruit peels, cooking grease, dog food, and sweet wrappers. To a bear's nose, that single bin can smell louder than a wide patch of forest. A bird feeder can hold black oil sunflower seeds with more than 100 calories in a small handful. A backyard apple tree can drop fruit every day for weeks. A campsite cooler may carry bacon, bread, peanut butter, chocolate, and fish smell in one sealed box that still leaks odor through tiny gaps. The bear does not know these things belong to people. It knows the smell means calories. That is where many conflicts begin. Wildlife managers often use the word attractant for anything that draws a bear closer to human places. Garbage is an attractant. Livestock feed is an attractant. Chicken coops, beehives, orchard fruit, compost piles, barbecue grease, and pet food left outdoors can all pull a bear across a boundary people thought was clear. In some mountain towns, bear-resistant garbage containers are built with heavy lids, locking bars, or latches that require hand movements difficult for bears to copy. The goal is simple. If the bear receives no food reward, the place becomes less worth remembering. This matters because bears learn quickly from success. A black bear that finds food on a porch may return at night. A grizzly that receives grain near a ranch may test the same area again. A bear that breaks into a cooler at a campground may begin checking other coolers, other tents, other picnic tables. The same memory that once tied salmon streams and berry slopes together can begin tying houses and roads into the feeding map. Roads add another kind of pressure. A road may cut across a valley bottom, where bears move between river, forest, and meadow. Vehicles arrive faster than animal movement evolved to handle. A bear crossing at dusk may be difficult for drivers to see, especially when dark fur blends into the shoulder of the road. Roads can also divide habitat into smaller pieces. When a forest is crossed by highways, fences, buildings, and busy recreation areas, the animal's old route can become a line of interruptions. A female with cubs may avoid noisy places and lose access to feeding areas. A young male searching for territory may be pushed toward towns. A denning slope that was once quiet may become surrounded by trails, cabins, or winter activity. The overlap becomes especially clear in the Arctic. polar bears depend heavily on sea ice because sea ice gives them a platform for hunting seals. Ringed seals breathe through holes in the ice and raise pups in snow-covered lairs. A polar bear can wait near those breathing holes and use smell, patience, and strength to catch the fat-rich food its body is built around. Seal blubber is dense fuel in a cold world. When sea ice forms later in autumn or breaks up earlier in spring, the hunting season becomes shorter. The bear may spend more time on land, where food is usually less rich than seals. Some polar bears eat bird eggs, carcasses, vegetation, or human refuse when they are ashore. Yet those foods rarely replace the energy gained from seal hunting on ice. The change reaches into reproduction too. A female polar bear needs strong fat reserves before denning and nursing cubs. If she enters the den with less stored energy, the pressure reaches the next generation before the cubs ever step onto snow. Other bear species face different versions of the same problem. Brown bears may lose salmon access when rivers warm, flood patterns shift, or human barriers change fish movement. Black bears may be drawn into suburbs as houses spread into wooded hills. Spectacled bears in the Andes can be affected when cloud forests are cleared or broken into smaller patches. Giant pandas depend on bamboo forests that must remain connected enough for animals to move, feed, and find mates. Each species meets the human world through its own food, its own landscape, and its own seasonal needs. The pattern is quiet but steady. Bears can live near people when food is secured. Travel routes remain open, and wild habitat still works. They struggle when the easiest calories are dangerous, when movement becomes broken, and when climate changes the timing of the foods their bodies expect. After all this, the bear becomes harder to see as a simple symbol. It is an ancient carnivore, a careful mother, a sleeper through winter, a memory keeper, a powerful forager, and a living body still trying to follow the old instructions written into its bones. Those old instructions remain inside the bear, even when the world around it changes. They reach back far beyond towns, roads, cabins, cameras, and names. A living bear carries a very long inheritance. Its family, Ursidae, belongs inside Carnivora, the mammal order that also holds cats, dogs, seals, weasels, and hyenas. Yet the bear took its own road through time. From smaller early relatives in the Miocene, through extinct cave bears and short-faced bears, into the 8 living species that still move across forests, mountains, ice, bamboo groves, and tropical trees. The bear body became a patient answer to a difficult world. That answer begins with weight and strength. The broad feet press fully into the ground. The claws stay visible at the ends of the toes. The shoulders carry enough force to turn stones, open rotten logs, climb trees, dig dens, break into insect nests, and pull fish from moving water. A bear's body can look slow until the moment it needs to move. Then the heavy shape becomes sudden, direct, and exact. Behind that strength is a world of scent. The nose gathers information from air, bark, soil, water, fur, fruit, blood, smoke, and old trails. A bear may smell a carcass beyond sight. It may find berries hidden by leaves, a cub nearby, a rival on a rubbed tree, or food stored badly near a campsite. For humans, a forest often begins with what can be seen. For a bear, the same forest is layered with chemical traces, each one fading, mixing, or growing stronger with wind and moisture. The year shapes the body as much as the land does. Spring can bring hunger after winter. Summer can bring grasses, insects, roots, berries, and fish. Autumn often becomes the season of urgency, when fat is gathered before cold closes over the ground. That fat is more than stored weight. It becomes fuel for the months when many bears eat nothing. It becomes water inside the body through metabolism, the process of breaking stored energy down. It helps carry a sleeping animal through a winter den beneath roots, snow, soil, or stone. Inside that den, the bear performs one of the quietest feats in mammal biology. Its heart slows. Its metabolism drops. Its body recycles waste instead of releasing it in the usual way. Muscles and bones are protected through months of stillness, far better than human muscles and bones would be. In that same darkness, a mother may give birth to cubs so small they seem almost impossible beside her. The cubs arrive blind, helpless, and lightly furred. Milk made from the mother's stored energy carries them through the first part of life. When they finally leave the den, their education begins on real ground. They learn which trees can be climbed. They learn the smell of danger. They learn where food appears and how the seasons move across a home range. Memory turns those lessons into a map, a salmon river, a huckleberry slope, an oak stand, a denning hillside, a safe crossing, a dangerous yard, a place where another bear once appeared. Each location can stay with the animal. That same memory has connected bears to people for thousands of years. Cave walls in Ice Age Europe, northern ceremonies, hunting stories, carved figures, family warnings, scientific collars, bear-resistant bins, park cameras, and conservation plans all belong to the human side of the relationship. People have feared bears and cared for them. People have taken from them and tried to protect them. The fascination has changed its tools, yet the animal at the center remains real. A bear still needs enough food. A mother still needs a safe den. A polar bear still needs sea ice to hunt seals. A black bear still follows scent toward fruit, insects, or unsecured garbage. A brown bear still remembers rivers where salmon return. After all of this, the bear is harder to reduce to a single meaning. It carries wilderness, but also anatomy. It carries power, but also hunger. It carries danger, but also care. There is evolution in the skull, weather in the fur, memory in the feet, winter in the fat, and ancient patience in the sleeping body. So when a bear moves away through spruce trees, across a gravel riverbank, over a mountain slope, or into blue-white snow, the shape no longer feels simple. It is a whole history walking quietly on four heavy paws. The head lowers. The nose reads the air. The season continues around it. Then the bear passes beyond view, still following scent, stored memory, and the old rhythm of the wild.